Hello dear students, we will start with solving problems from exercise 8.3. Let's start with the first one. Square root of 36, as we know, it's just 6. Under B, we have square root of 100, that's just 10, because 10 squared is 100. Under C, we get negative square root of 121. So we copy the sign negative. Now square root of 121 is just 11. Under D, we get square root of 16x squared. If we separate by the property that we studied, if we separate this into square root of 16 times square root of x squared, this makes 4 times. Normally it should be absolute value of x, but we can just write there x because let's assume x is positive. Now under E, it's square root of 25y squared, which again using exactly the same property would be square root of 25 times square root of y squared. So it should be, actually it's 5 here, so 5. Square root of y squared is just y. And the last one, under F, we have square root of 121 times a to the power 4. We can separate it again. Square root of 121 times square root of a to the power 4. That makes it 11a squared. Square root of a to the power 4 being a squared, because a squared all squared is a to the power 4. Let's continue with the second exercise. I can write the answers here for most of these exercises. So it would be square root of 3 times square root of 3. We can write it as square root of 3 times 3. 3 times 3, which makes it square root of 9, which is just 3, or as shortcut we can just write it square root of 5 squared. Cancel, cancel, that's just 5. You know that cancellation is only allowed if the number inside the radical sign is positive, which in this case indeed it was positive. Now what do we have? We have square root of 3 times square root of 12 will be 3 times 12, that makes 36, which is just 6. Square root of 3 times square root of 27 will make square root of 81. And square root of 81 is just 9. Alright, let's continue here. For E, we have square root of 2x times square root of 8x. If we put them under the same radical sign, we get 2x times 8x. And 2 times 8 is 16x squared. Just the same as the previous exercise, we can separate it into square root of 4, actually square root of 16, which will be 4, times square root of x squared. That's 4x. Under F, we get square root of 6xy. Now we are starting to deal with more than one unknown, like xy in this case. So just the same, follow the same procedure like previously. You get 6xy times 24xy. Now 6 times 24 is 144 times x squared times y squared. Now this is 12xy. I skipped a step to separate it into 3 roots, square root of 144, square root of x squared, square root of y squared, but we will just get the same answer there. Alright, let's continue. Under G, we get 3a times square root of 5a. That makes it square root of 15a squared. As you can see, 15 is not a square root of an integer, so as we call them in square numbers, 15 is not a square number, but a, it is a square, so a squared is square root of a squared. It's just a root of 15. All right. Under age, we have 3 root of 2x times 4 times root of 18xy squared. I think we can just add the multiply actually 3 and 4 and multiply 2x times 18xy squared. Right, 3 times 4 will make 12 times the root of 2 times 18, that's 36, x times x squared, y times y squared, which will be 12 times. Now, square root of 36 is just 6, square root of x squared is just x, and square root of y squared is just y. And now 6 times 12 makes 72xy. Let's continue with the next exercise. Perform the operations. All right, this exercise is just adding radicals that have a common part. Like in this case, the common part is square root of 3 and square root of 3. So how do we add that? Well, 3 root of 3 plus 2 root of 3 makes 5 root of 3. Same goes here. We have a common radical, but now we should pay attention. We have a 1 in front. We don't write it because it's not necessary. So 6 and 1 makes 7 root of 5. Same goes for C, but now the unknown is square root of x. I mean, the root is just an unknown number, root of x. So negative 5 root of x plus 5 root of x, negative 5 plus 5, it's just 0 root of x. But 0 times a number will be just 0. Let's check under D. What do we have under D? We have a constant 1 in front. So 1 root of 6 minus 3 root of 6, it's negative 2 root of 6. Let's solve now under E and under F separately. We have square root of 18 plus 2 root of 72. All right. Can we rewrite this number 18, express it as product of a square number and another number? Well, I think it's just 9 times 2. Plus 2 times 72, I think we can rewrite it as 36 times 2. Great. Now, just using previous properties that we mentioned, 3 times root of 9 is 3. All right, let's write it for now here. Root of 9 times root of 2 plus 2 times root of 36 times root of 2. All right, let's continue here. So root of 9 is, I'm copying this 3. Now root of 9 is 3 times root of 2 plus I'm copying this 2, and root of 36 is just 6 root of 2. So let's multiply here and here. What do you get? You get 9 root of 2 plus 12 root of 2. That makes 21 root of 2. Perfect. And the last exercise here would be root of 80 minus square root of 125 plus root of 45. All right. Again, can we write this number 80 as a product of a number, a square number, times another number? All right, let's try. We can write it as 16 times 5 minus 125 is 25 times 5, and 45 is actually 9 times 5. All right. Sometimes it may take some tries to figure out which numbers are these, but anyways, it's easy. It will be 4 root of 5. I'm skipping a step here. 5 root of 5 plus 3 root of 5. Now 4 root of 5 and 3 root of 5 makes 8 root of 5. 8 root of 5 minus 5 root of 5. 8 minus 5 makes 3 root of 5. Perfect. Let's continue with another exercise. Under G, what do we have? We have root of 75. Let's continue directly here. I think we can rewrite it as 25 times 3. And 108, we can express it as 36 times 3. 48 as 16 times 3. And 27 as 9 times 3. All right, let's continue. So this would be 5 root of 3 plus 6 root of 3 minus 4 root of 3 plus 3 root of 3, which will make 5 and 6, 11, and 4, that's 14, minus 4, 10 root of 3. Under H, well, we can perform pretty much the same operations here as well. So let's see. Square root of 9x cubed plus 16x cubed minus 4x root of 25x. Let's continue here. I think we can rewrite it as square root of 9 times square root of x squared times square root of x. Why are we doing this? Well, because it's x cubed, we can separate it as x squared times x, which after finding the square root of x squared, it will be just x, so we are leaving only one square root of x here. Do the same for the rest of these terms. It will be square root of 16 times square root of x squared times square root of x minus 4x root of 25 root of x, and perform the same operations like previously. This square root of 9 is just 3 square root of x squared. Actually, it's absolute value of x, but we will take it as x is positive. Plus square root of 16 is 4x root of x. Minus, now we have to multiply these two numbers. This would be not by 25, but by the root, by the whole root. So root is 5. So square root of 25 is 5. 4 times 5, it will be 20x root of x. All right, so now 3x root of x plus 4x root of x minus 20x root of x. It will be just like adding 3 plus 4 minus 20. And that makes how much? 7 minus 20. Let's write it 7x root of x minus 20x root of x. That's negative 13x root of x. Root of x. Great. Let's continue with exercise I here. What do we have? We have square root of 2.25 minus square root of 2.89, 89 actually, 1.44. All right. Now, I think we can express these decimal numbers as fractions, like this. And doing the same, 289 over 100 like this, and 144 over 100. Now, by using a property that we studied, we can separate roots like this. Square root of 225, square root of 100 minus square root of 289 over square root of 100 plus square root of 144 over square root of 100. Now square root of 225 is 15 over 10 minus this is 17 over 10 plus 12 over 10, which makes 15 and 12, it's 27 minus 17, that's 10 over 10, it's just 1. All right, let's continue with the last exercise here. Let's continue with the last exercise, which is square root of, let's clear this one. All right, under J, we have now square root of 0.9 in period, like repeating nines. If you recall, like 0.9 repeating, we express something like this equals to x, because let's say we don't know what's the value of that 0.9 repeating as fraction. So we can rewrite it, we can multiply by 10 here, and what do you get? You get 9.9 in period is 10x. And if you subtract second equation minus first equation, let me write something like this: second equation minus first equation, so this one minus this one side by side, we get 9.9 minus 0.9 equals 10x minus x. Now this is 9 is equal to 9x, so x is 1. Great. We will skip steps for the second one, so this one is just 1 here. Now you can try the rest, like it will be 2 wholes and 7 over 9 here, plus here it will be 1 whole and 7 over 9, plus 4 over 9 here. All right, let's continue. Square root of 1 is 1, minus 2 times 9 is 18, and 7, that's 25 over 9, plus 16 over 9, plus 2 over 3. That makes it 1 minus 5 over 3 plus 4 over 3 plus 2 over 3. So let's rewrite this one as 3 over 3. 2 and 3 it's 5, and 4, 9 minus 5 it's 4 over 3. All right, next exercise is exercise 6. Let's continue with the first one. Under A, we have square root of 3 plus 2 root of 2. Well, there was a formula that we studied during the lessons, and it was square root of m plus square root of n was square root of a plus 2b if a is m plus n and b is m times n. So we will just apply this formula, but also this formula works for negative numbers as well. All right, so can you give me two numbers that multiply to 3 and add up to 2? I think those are, add to 3 and multiply to 2. It's the number 2 and 1. So this should be square root of 2 plus square root of 1. We can just rewrite it as 1 plus root of 2. Under B, same goes here. Square root of 5 minus 2 root of 6. Now, two numbers that add up to 5 but multiply to 6. It must be root of 2 and root of 3. Because the formula is with minus, we should add minus. But pay attention here, this is a wrong order. If you check the formula, it was saying n should be greater than n. In the case that these are positive, it doesn't matter. But in the case that these are negative, it actually matters. So, square root of 3 minus square root of 2. Under C, we have square root of 8 plus 2 root of 12. Two numbers that add up to 8 multiplied to 12. it should be root of 6 plus root of 2. Under D, we have square root of 11 plus square root of 96. Now, if you pay attention, this root here is not of this form because clearly it's missing this coefficient 2 in front of square root of b. So we are missing a 2 here. We should get that 2. In order to get that 2, there are two ways. One of those methods would be to factor out a 4 from this 96. We'll see why now, just in a minute. So 11 plus square root of 4 times how much? It's 96. It should be 24, I think. So now we can rewrite it as 11 plus 2 root of 24. Now this root that we got here is of this form because there is a 2 there. All right. Now just solving this part exactly like we solved A, B, and C. Two numbers that add up to 11 but multiply to 24. Because 24 has more multiples, you may check more times, but you'll see that it's just square root of 8 plus square root of 3. Perfect. Now under E, we get square root of 8 minus 2 root of 7. This is already in the requested form, so it's given on the requested form. For that reason, we can directly continue from here. Two numbers that add up to 8 but multiply to 7. I think it should be only root of 7. These numbers should be 7 and 1, so root of 7 minus root of 1. Now root of 1 being just 1, we can rewrite it as root of 7 minus 1. Under F, we have square root of 5 plus square root of 24. Just the same, we can rewrite it as 4 plus 2 root of 6. Two numbers that add up to 5 multiplied to 6 would be root of 2 plus root of 3. Under G, we get 7 minus 4 root of 3. Now, here we can clearly see we have a coefficient 4 in front of the root, and we have to make it 2. So how would you do that? Well, it will be 7 minus 2 times 2 root of 3, like this. Now, clearly we got this coefficient 2, but the rest, this part here, we want to combine to make it a pure root out of this. So that will be something like this, because 2 is actually equal to square root of 4. That makes 7, actually first square root, minus 2 root of 12. Two numbers that multiply to 12 and add up to 7, it should be 3 and 4. So square root of 4 minus square root of 3. It's not the opposite because n should be greater than n. And we now, because 4 is a square number, we can rewrite it as 2 minus root of 3. All right, let's clear up this part and let's continue. So, under H, we have square root of 3 plus square root of 8 plus square root of 3 minus root of 8. Now, square root of 8 being 2 root of 2, we can rewrite it as this. And the same goes for the second root as well. So 3 minus 2 root of 2. And now give me two numbers that add up to 3 multiplied to 2. It's actually exactly the same like under a. So it will be a root of 2 plus root of 1 plus, same goes here but with minus sign, root of 2 minus root of 1. These two will cancel out. So finally we get root of 2 plus root of 2. It's 2 root of 2. Let's check under I. We have square root of 4 plus square root of 15 minus square root of 4 minus root of 15. And now if we try to factor out of 4, you'll see that it doesn't work. If you try to get some kind of 2 in front of this root, it won't work, but there was something that we mentioned during the lessons. Now I can multiply this root here, 4 plus root of 15, by square root of 2 and divide by square root of 2 as well. Let me write it here on a new row. So it will be square root of 4 plus root of 15 times root of 2 over here root of 2 as well. Now minus exactly the same for the second root. I mean, it's not 12, it's 15 over root of 2 times root of 2. Now if we multiply these two roots, we will get denominator root of 2 minus again here denominator root of 2. 2 times 4, 8, plus 2 times root of 15, 2 root of 15 under this root, and the same goes here but with minus sign, just like this. All right, now we can we find two numbers that add up to 8 but multiply to 15? It should be 3 and 5. So root of 5 plus root of 3 over square root of 2 minus square root of 5 minus square root of 3 over square root of 2. We can put them under the same square root. Now square root of 5 minus square root of 5 cancels, so square root of 3 and square root of 3 makes 2 square root of 3. But let me write it step by step here. So it will be square root of 3 minus negative square root of 3. That will make it positive, so 2 root of 3 over root of 2. We have two more exercises. Let's finish with those ones as well. So under F, we have square root of a plus 2 plus square root of 8a minus square root of a. All right. So this root is not of this form. Obviously, the coefficient 2 is missing in front. So let's try to get that 2 as a coefficient in front of the root inside the radical sign. So a plus 2 root of 2a. Why? I just separated this 8 as 4 times 2 minus root of a. Now, can you give me two numbers that add up to a plus 2 but multiply to 2a? Obviously, those two numbers are a and 2. Now, this is only from this square root. Now, I'm just copying the second part, minus root of a, cancel, so only root of 2 is left. And the last exercise from exercise 6, it's square root of 2 plus 2 root of 4 plus root of 12. We should start from the innermost root. So let's try to perform operations on this innermost root. So let's see what will happen. I'm copying everything else. 2 plus 2 root of, well, I can rewrite this root of 12 as 2 root of 3 because it's 4 times 3 and square root of 4 will be just 2. So 2 root of 3. Again, I'm only performing operations here. So just look at this red rectangle here. Now, give me two numbers that add up to 4 and multiply to 3. That makes it how much? That makes it root of 3 plus root of 1. All right, next, let's see. I think we can get rid of some of those brackets like this. So 2 root of 3 plus square root of 1 being just 1 here. 2 times 1 is 2. So finally we get 4 plus 2 root of 3. Oh, it's exactly the same. It's exactly the same expression like we solved previously. So it will be exactly the same result again. So square root of 3 plus square root of 1. This being square root of 3 plus 1. All right, done with the sixth exercise. Next, here, as we mentioned during the lessons, this is just like a problem with nested brackets, so brackets inside brackets. We will start from the innermost part, the rest will be all copied. So what do you get? 32 plus square root of 21 minus square root of 23. Now root of 4 is just 2. So again, let me color this part. So now we will just add 23 and 2. That will make 21 minus root of 25. Now square root of 25 is just 5. And 25 minus 5 is just 16. Square root of 16 is 4. That makes it square root of 36, which is just 6. Alright, the same goes for b. Let's solve b here. We have square root of 7 over 3 plus square root of negative 2 over 9 plus square root of, we should extend these ones to make them equal, plus square root of 9. Alright, so what do you get here? You get square root of 7 over 3 plus square root of negative 2 over 9 plus square root of 6 and square root of 9 being just 3. So we copied everything except the square root of 9 there. Now again we copy everything, 7 over 3 plus root of negative 2 over 9 plus, now 3 and 6 adds up to 9, square root of 9 being 3, and 7 over 3 plus square root of negative 2 over 9 here. 2 over 9 plus, instead of writing this just like 3, we can add the denominator 1, but we will have to make a common denominator, so multiply by 9 here and here, so enlarge this fraction by 9. That makes it 27 over 9. Let's continue. 7 over 3 plus square root of negative 2 over, actually let's perform calculation, 27 minus 2, that's 25. Alright, and 7 over 3, square root of 27 is just 5, and square root of 9 is 3. So this makes square root of 12 over square root of 3. Now 12 over 3 is 4, and square root of 4 is just 2. Right, we can solve here under D because we have enough space here. Now, exactly the same as in previous cases, 8 times square root of 16 times square root of 1 over 96 times square root of 9. Well, square root of 16 is 4, so let's write it just 4 here. Now, this will be 8 times square root of 16 times square root of 1 over 96. Square root of 9 times 4, it's 36. Square root of that is just 6. Alright. 8 times 16 times. Now, I think we can cancel both by 6, this one here and here, and 96 divided by 6, it should be 16. So 1 over 16, square root of 1 over 16. We can perform calculations here, and we should get something like 1 over 4. Let's continue here. Separate these two exercises. That makes it 4. Square root of 16 times 1 over 4 is just 4. So you get square root of 8 times square root of 4. Square root of 8, square root of 4 being 2, which makes 16, and that's 4. Alright, the same way as we used to solve B and the rest, we'll solve exercise D. And what do we have here? We have root of 13 plus root of 6 plus root of 6 plus, instead of root of 9, square root of 9 is just 3. Now 3 and 6 is 9, so 13 plus square root of 6 plus square root of 9 is 3. Now again the same, square root of 13 plus 3, that makes it square root of 16, that makes it 4. Next one. Now we have some infinite radicals here. We solved at least one of these problems during the lessons. Let's try now. A, it's square root of 2, root of 2, root of 2, repeated infinitely many times. It's equal to x. If you recall, like if this expression is equal to x, then exactly again this expression is also equals to x. So what do you get? You get square root of 2x is equal to x. Well, if you square both sides, you get 2x is equal to x squared. And here there are two possibilities. Either x, let's label it x1, like the first solution for x, either it's going to be 0 or it's going to be 2. Now we can clearly see it's not 0 because this number is something positive. It's a positive number. So this is not a solution. Let's write here not a solution. So that leaves us with only x being 2. So this root of 2, root of 2, root of 2, it should be equal to 2. Let's try now under b. What do you get under b? Pretty much the same. 3 root of 3 root of 3 root of 3 dot dot dot, it's equal to x. Well, if 3 root of 3 root of 3 root of 3 is equal to x, the same goes here, from here to here, as well as x. Well, now what do you have? You have 3 root of x is equal to x. Alright, now I think we can square both sides and we get 9x is equal to x. Using the same logic as previously, one of the numbers that will fulfill this condition would be 0, which clearly is not a solution. But the second one is squared here. X squared. The other one is x equals 9. So this is a valid solution. Let's check the same logic for under C, and we get square root of 3x plus square root of 3x plus dot 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 equals to 9. Exactly the same. If this whole expression is 9, then the stuff inside is 9 as well, so this must be 9. So you get square root of 3x plus 9 is 9. Square both sides to get rid of this root, so 3x is equal to 3x actually plus 9 is equal to 81, which is 9 squared, like when we square both sides. Get rid of this negative 9, so 3x is 18 minus 9, 72. Divide both sides by 3 and you get x is equal to 24. So x should be equal to 24. Next, we have some roots here. We will solve some of these problems because most of these are very similar. So 5 times root of 2, like we just multiply this times this, this times this. 5 times 2 it's 10, 5 times 3 it's 15. 7 times 1, root of 7 times 1 is just root of 7. Root of 7 times root of 7 is root of 7 squared. I'm just showing it once, but the rest is the same, like square and root cancels. That makes it just 7. Alright, let's solve 1 and skip 1. Root of 2 times root of 8 would be root of 16 plus root of 2 times root of 32 would be root of 64, root of 16 being 4 and root of 64 being 8. That adds up to 12. Here the same, if we recall, there was a famous formula a minus b times a plus b is equal to a squared minus b squared. We can always use brute force here to just multiply everything, but we can shortcut it using this formula. So that makes us 3 squared minus square root of 5 squared, and 3 squared is 9 minus root of 5 squared cancels 5, so the answer is 4. Under h the same, but now the first term, like which is represented by a here, the first term is this a and this is b. So what do we get? We get 2 root of 3 squared plus, actually minus 2 squared. So 2 squared is 4, root of 3 squared is 3, minus 2 squared is 4. That makes it 12 minus 4, that makes it 8. Alright, now here we can either try to multiply these numbers directly here, or maybe we can get some good factorizations. Maybe it will be easier to factorize first. This number square root of 12, let me show here, square root of 12 is actually square root of 4 times square root of 3, which makes it 2 root of 3. Oh, so it's something similar. let's rewrite it as negative 2 root of 3, negative 2 root of 3 plus 2 root of 2. Alright, then we should multiply this whole expression by root of 2 plus root of 3. I see something in common. Like, look, there is this 2 and this 2 here in common. Sorry, I miswrote this root here. It shouldn't be. Yeah, like this. Now, I think if we factor out a 2, what do you get? You get, it should be negative root of 3 plus root of 2. But to make it look like the formula here that we are using, I will just switch order to root of 2 minus root of 3 times root of 2 plus root of 3. Now what do you get when you multiply these two parts? Here and here, we get square root of 2 times square root of 2 is 2, minus square root of 3 times square root of 3 is 3, so this is negative 1. The final answer is just negative 2. Alright, let's clear this sheet and let's continue with K, L, and N because it will require a little bit more space. So under K, we get square root of 2 plus 1, square root of 2 minus 1. That makes it how much? Square root of 2 plus 1, square root of 2 minus 1. Now we can use the formula a minus b, a plus b. So copying the square root, and this is 2 minus 1. Let's make it shorter a bit. 2 minus 1, and that's 1. Yeah, it's exactly 1. Under L, we can combine it directly under the same root. So we get 2 root of 3 plus 3 over 2 root of 3 minus 3. Again, it's the formula a minus 1, a plus 1. So 2 root of 3 all squared minus 3 squared. That makes 2 squared is 4, root of 3 squared is 3 minus 9. And I made it a little bit longer. Let's shorten it a bit. Yes. That makes it 12 minus 9, 3. So that's it, square root of 3. And the same for under N. So we have square root of 5 plus 2 root of 3 times square root of 2 plus root of 3 times square root of 16 minus 9 root of 3. Alright, let's multiply the first two radicals here. We will put them under the same radical sign, all of these, and then we'll multiply 5 plus 2 root of 3 times 2 plus root of 3 times 16 minus 9 root of 3. Alright, 5 times 2 makes 10. 5 times root of 3 is 5 root of 3. 2 root of 3 times 2 makes 4 root of 3. And 2 times root of 3 times root of 3 makes 2 times 3, 6. All of this as answers should be multiplied to 16 minus 9 root of 3. Alright, that makes how much? 10 and 6 it's 16 plus 9 root of 3 times 16 minus 9 root of 3. Oh, we just solved these kind of problems, a plus b, a minus b, so it should be 16 it should be 16 squared minus 9 root of 3 squared. So 16 squared is 256. 81 minus 81 times 2 would be 243, like this. And 66 minus 3, it's 3, 5 minus 1, 13, so it's square root of 13. Hopefully we don't have any mistakes in calculations. Next, rationalization. Alright, there was a process called rationalization, which meant to get rid of the radicals on the denominator. So we actually only care what's going on the denominator. So it's this part here. Right, what will you do here? Well, in order to get rid of that square root of 3, we should multiply by square root of 3. But multiplying by a denominator square root of 3 requires also to write in the numerator something. If you write 1 or 0, by 0, it means you are multiplying both sides, the numerator by 0, which just changes the whole fraction to 0, so you can't multiply by 0. Well, multiplying by 1 over root of 3 will change the value of the numerical expression, which we clearly don't want. That means we multiply by square root of 3 over square root of 3, which in itself it's 1. And 1, we know that a number times 1, it's exactly the initial number. Now square root of 3 times square root of 3 is just 3. So here it's 3 root of 3 and cancels. That makes how much? Just root of 3. Let's check under B. Same goes here. Root of 3 plus root of 2 over root of 6. Again, we multiply both sides by root of 6 over root of 6. And in the denominator we got 6. In the numerator we will multiply like with brackets, like this. And what do you get? Square root of 6 times square root of 3, square root of 18 plus square root of 12 over 6. Yes, we can do something to simplify a bit if we want. Like 18 is actually 9 times 2, so it will be 3 root of 2 plus 12 will be 2 root of 3 over 6. Now we can separate it into square root of 2 over 2 plus square root of 3 over 3. Try this one, like separating this fraction into two parts and canceling 3 and 6 here. Or as well 2 and 6. Alright, under C we get negative 1 over root of 11. Same goes here, multiply by root of 11 over root of 11, and that makes negative square root of 11 over 11. Under D, we get 1 plus root of 2 over 4 root of 3. Now, it's not necessary to multiply both numerator and denominator by 4 root of 3. Actually, it's enough to multiply just by root of 3, because multiplying by 4 root of 3 won't help at all in getting rid of this radical here. So it will be 4 times root of 3 times root of 3 is just 3. Now 1 times root of 3 is root of 3, and 2 times root of 3 is root of 6, which makes it square root of 3 plus square root of 6 over 12. And that is not square root of 9 over 12. Under E, we have 1 over 1 minus root of 2. We should multiply here by a number. Now, we mentioned during the lessons we should multiply by the same denominator but with opposite signs. Why we are doing this? In order to use the formula a minus b times a plus b, and that formula will help us to get rid of the denominator, the root in the denominator. So 1 minus root of 2, 1 plus root of 2. And here we have, because we're multiplying only by 1, we have 1 plus root of 2. That's left 1 plus root of 2 over 1 times 1, it's 1 minus root of 2 squared. 1 plus root of 2 over 1 minus 2. That leaves us with denominator negative 1, so negative 1 plus root of 2. We are done till E, so let's continue with F. I have to erase everything here. So under F, we get something similar, negative 2 root of 3 plus 2. Now again, we should multiply both numerator and denominator by square root of 3 minus 2, square root of 3 minus 2. All right, so finally, what do we have? Negative 2 root of 3 plus 2 times 2 makes 4. And on the denominator, we get square root of 3 squared, which is 3, minus 4, so negative 1, negative 2 root of 3 plus 4, which will be negative 2 root of 3 minus 4 over negative 1, and that is 2 root of 3 minus 4. Under G, you get root of 3 plus 1 over root of 3 minus 1, exactly the same method. You multiply both denominator and numerator by square root of 3 plus 1, and you get square root of 3 plus 1 here as well. And let's skip some steps. Square root of 3 times square root of 3 is 3 minus 1. On the numerator, you'll get 3 plus 2 root of 3 plus 1 after performing multiplication here. So you get 4 plus 2 root of 3 over 2. That makes it 2 plus root of 3 under G. Under H, we got 4 over 3 root of 3 plus 2. Same, multiply here by 3 root of 3 minus 2, 3 root of 3 minus 2. And what do you get? You get 3 times 3, 9 times 3 minus 4, 12 root of 3 minus 8. So 12 root of 3 minus 8 over 9 times 3, 27, minus 4, it's 23. You can try separating, but there is nothing better we can do to simplify this expression. Under I, we get root of 10. We get root of 10 over 2 root of 7 minus 5. Here we will multiply by 2 root of 7 plus 5, 2 root of 7 plus 5. That makes it root of 10 times root of 7 is root of 70. Here, 2 root of 70 plus 5 root of 10. And the denominator will get 4 times 7 minus 25. And that would be 2 root of 70 plus 5 root of 10 over 2. 4 times 7, it's 28 minus 25, that's 3. And this is the best we can do. Next, under J, so what do you get under J? It's square root of 3 over square root of 2 plus square root of 3. That makes, we should first multiply here by square root of 2 minus square root of 3. Same on the numerator. And we get 2 minus 3, square root of 6 minus 3, that makes it negative square root of 6 minus 3, which is 3 minus square root of 6. It looks a bit better. We got this negative because the expression here is negative 1. K, we got 2 root of 2 over square root of 3 minus square root of 5. Right now, this expression, we can clearly see we have a root inside the root, so this directly should give us an idea, like we should use the formula where there was a 2 here, 3 minus 2 root of 5, if you recall it from the lessons. Now, in order to get that square root of 2, I will have to multiply both numerators and denominators by square root of 2. So what do I get? I get 2 times root of 2 times root of 2, which makes 4. But in the denominator, I will get 3 times 2, 6, minus 2 root of 5. All right. Now, I think we can do something here. Two numbers that add up to 6 but multiply to 5. It must be square root of 5 and square root of 1, which just in case it's 1. All right. Now we can continue with... let's continue here. So we can multiply again the same square root of 5 plus 1, and here square root of 5 plus 1. And what do you get? It would be 5 minus 1 over 4 root of 5 plus 4. So it will be 4 root of 5 plus 4 over 4. When cancels, it's square root of 5 plus 1. And the last one, under L, we will have something similar maybe. Now it's 10 plus 2 root of 21, square root of this whole thing, square root of 7 plus square root of 3. So what do we get here? Now two numbers that add up to 10 and multiply to 21. Those two numbers are 7 and 3, obviously, so it will be square root of 7 plus square root of 3. We are not cancelling square root of 3 and square root of 3, we are cancelling the whole expression. We can't cancel square root of 3 and square root of 3, it's addition, it's not multiplication, so we are adding. That means the whole expression is just 1. Next, some similar exercises to the previous ones. Now we have to add these numbers. There are two different ways we can do it. There are two different ways we can approach it. One way being first adding these fractions, and second is first rationalizing these fractions. So let's rationalize. The first expression after rationalization will be square root of 3 over 3, and the second one will be square root of 2 over 2. Now, when we add these, 2 root of 3 plus 3 root of 2, just like we used to add normal fractions. Let's try the second one here. We can rationalize the first fraction. It will be 3 root of 3 minus 1, and here the denominator will be 3 minus 1, plus the denominator will be the same here, so 2 root of 3 plus 1. All right, we can get something here. Actually, it's not plus, here it's minus. So we'll get a common denominator 2, so 3 root of 3 plus 2 root of 3 makes 5 root of 3 minus 3 plus 1, negative 3 plus 2, actually, it's negative 1. And this is the best we can do here. Let's perform same operations here. Under C, we can rationalize the first fraction to 5 times 2 root of 3 plus root of 11 over 4 times 3 minus 11. And the same goes for the second fraction, which will be 2 times 2 root of 3 minus root of 11 over 4 times 3 minus 11. So the common denominator 4 times 3 is 12 minus 11 will be 1. Now 5 times 2, 10 root of 3, 10 root of 3 plus 5 root of 11 minus 4 root of 3 plus, it's plus because negative times negative will be positive, so 2 times 11, root of 11 actually. So 10 root of 3 minus 4 root of 3 makes 6 root of 3, 5 root of 3 plus root of 2 root of 3, that's 7 root of, not 3, actually it's 11. And the last one under D, exactly the same process. We rationalize these two fractions. I trust you can do that one. So you'll get 3 plus, not plus, minus 4 times 2. On the numerator we'll get 4 root of 2 times square root of 3 minus 2 root of 2 here, minus 2 root of 3 and square root of 3 plus 2 root of 2, something like this. So 3 minus 4 times 2 on the second fraction as well. You can try these ones on your notebooks and most probably you'll get the same answers. If there is a calculation mistake, let me know it. So you get 3 minus 8, that's negative 5. The second one has common denominator, also negative 5 as well. Now let's get rid of these multiple brackets. We need to expand these brackets. So 4 times root of 6, that makes it 4 root of 6, minus 8 times 2. And the second one, on the second fraction, we'll get 2 times 3 plus 4 root of 6. Yes. And because we have a common denominator, negative 5, we have 6 root of 6 minus 16, negative 2 times 3, it's negative 6. Now negative 4 times root of 6, it's negative 4 root of 6. It's not positive because when we multiply this one here as well, we get negative number there. Alright, let's keep for now this denominator negative 5. So 6 root of 6 minus 4 root of 6 is 2 root of 6. Negative 16, negative 6 is negative 22. We can just rewrite it as 22 minus 2 root of 6. Alright, let's try under A. We can separate these two fractions back to addition, so it will be like square root of 5 plus 2 over square root of 5 minus 1 minus square root of 5 minus 2 square root of 5 minus 1, something like this. Now if you use rationalization on the first fraction here, we'll get 5 minus 1 on the denominator and 5 minus 2 plus 5 minus 2 plus root of 5 here, and on the second fraction you'll get again 5 minus 1 in the denominator after you square it and cancel those square roots and here and for root of 5 and negative 1. You'll get 5 plus 2 minus 3 root of 5. Alright, that makes it how much? It makes it 3 plus root of 5 over 4 minus 7 minus 3 root of 5 over 4. We can separate this into square root of 3 plus root of 5 over 2 minus square root of 7 minus 3 root of 7, we can write it as square root of 45. Actually, 3 root of 5 over 2. Alright, now I think we can use something that we used to, let's multiply the first fraction by square root of 2 over square root of 2 here. Why would we do this? Well, and the same for the second fraction as well. Why would we do this? Well, we want to get these fractions into one of those previous forms that we can use the formula later. And the formula was square root of 6 times square root of 3 times 2, it's 6 plus 2 root of 5 over 2 root of 2 minus, alright, we can put it under the same root, I believe, under the same denominator here, sorry. Minus square root of 7 times 2 makes 14, minus 2 root of 45. Great, so this root here give me two numbers that add up to 6 multiplied to 5. Those are square root of 3 plus square root of 2 minus, give me two numbers that add up to 14 and multiply to 45. The product is 45, so those are 9 and 5. It should be in this order from largest to smallest. So that makes it 3 square root of 3 actually. Square root of 3 plus square root of 2 minus 3 plus root of 5 over 2 root of 2. How do you rationalize now this root of 2? Again, we multiply by square root of 2 over square root of 2, and that would make it our final answer, square root of 6 plus 2 minus 3 root of 2 plus 10 over 4. So this is how we did rationalization under A. Let's continue under B. Under B we have 1 plus root of 2 over this whole square root of 2 plus square root of 11 plus square root of 72. If you pay attention, we can perform some operations here inside this part. So inside this rectangle here, I'm copying everything else except that innermost part. Now here, I can rewrite 72 as 4 times 18, so it would be square root of 11 plus 4 times 18 under same square root, which will make it square root of 11 plus 2 root of 18. Give me two numbers that add up to 11 and multiply to 18. Those two numbers are 9, so square root of 9 plus square root of 2. Alright, let's continue. So we get 1 plus root of 2 over, and here it will be square root of 9 is just 3 plus 2 root of 2. Give me two numbers that add up to 3 and multiply to 2. Those two numbers are square root of 2 and square root of 1. And here 1 plus square root of 2, which is the same expression, cancel, it's just 1. And the last exercise from this exercise set, it's exercise under C. I just want to show for one of these, for example, one of these terms, 1 over 3 root of 3 plus root of 2. After rationalization, what do you get? Root of 3 minus root of 2, root of 3 minus root of 2. Well, you'll get 3 minus 2, here square root of 3 minus square root of 2. 3 minus 2, it's just 1, so the final answer is 3 minus 2. We can generalize this one, so what do you get? Here we will get square root of 2 minus 1 plus square root of 3 minus square root of 2 plus square root of 4 minus square root of 3 dot 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 plus square root of 100 minus square root of 99. Now 2 and 2 cancels, 3 and 3 cancels, 4 and next cancels, negative 99 cancels. What's left? Only 101. So square root of 100 minus 1. Square root of 100 is 10 minus 1, it's just 9. Right, that was it. See you next time.